Now in this video, we shall study differentiability. A function fx is not differentiable everywhere. We have to check its differentiability at any point. Chapter is very important. In every competitive exam, there is always one question from differentiability. I shall try my best to simplify this chapter so you may do the question orally. Before doing this chapter, we do use limit, step function, continuity. So before studying this chapter, you have to go through previous videos about step functions, about limit, and about continuity. So what it says, a function fx is differentiable at x equal to a if limit h tends to 0, f of a plus h minus fa upon h, this is called right differentiation, is equal to limit h tends to 0, f of a minus h minus fa upon minus h. Then function is called differentiable at x equal to a. Let us see what it says. Right differentiation is equal to left differentiation, then function is differentiable at x equal to a. Now, every question can be done with the help of this basic result, but it is little bit lengthy method to do the question orally. So, what we shall keep in mind, first thing, if a function is a step function and if it is defined in different ways in left of a and right of a, then you differentiate the function in left and right. If they are equal, function will be differentiable at x equal to a. First point, I am repeating it again. If a function is a step function and it is defined in different ways in left and right of a, then you differentiate in left and right. If both differentiations are equal, function will be differentiable, otherwise not. Second thing, polynomials are continuous and differentiable everywhere. Polynomials are continuous and differentiable everywhere. Third, if a function is not continuous at any point x equal to a, then it shall not be differentiable at x equal to a. But if a function is continuous at x equal to a, it may or may not be differentiable at x equal to a. I am repeating it again. Continuity is necessary for differentiability, but it is not sufficient. Function is not continuous at x equal to a, it shall not be differentiable at x equal to a. But a function may be continuous at x equal to a, it may or may not be differentiable at x equal to a. Fourth point is this, limit x tends to a, fx minus fa. Limit x tends to a, fx minus fa upon x minus a if this limit is finite, function will be differentiable at x equal to a. If this limit is finite, function will be differentiable at x equal to a. Keeping all these points which I have explained you, if you apply these rules, you can do every question orally. You can do every question orally. So let us see, illustrate it. What is telling fx equal to greatest integer x, then correct statement is this is greatest integer. So naturally you have to go through the video step function. What is saying? Continuous at x equal to 0, discontinuous at x equal to 0, continuous on x equal to 0 but not differentiable, neither continuous nor differentiable at x equal to 0. If you have done the chapter of continuity thoroughly, you can see yourself that greatest integer x, limit h tends to 0, greatest integer 0 plus h shall go to 0, limit h tends to 0, 0 minus h shall go to minus 1, left limit is not equal to right limit, so function is not continuous at x equal to 0. If it is not continuous at x equal to 0, then what I told you, it shall not be differentiable. So answer is neither continuous nor differentiable at x equal to 0. What I told you, questions of the differentiability are always mixed with continuity, and to test them we do require step functions, limit, continuity, everything. So let us see second example. fx equal to x sine 1 upon x is not equal to 0, x equal to 0 when x equal to 0. In the previous video, we have done this question. Fx equal to x sine 1 upon x is continuous at x equal to 0. So one thing is sure, this function is continuous at x equal to 0. Now let us see what is the matter of differentiability. So limit x tends to 0, fx minus f0 upon x minus 0. This will be equal to limit x tends to 0, sine 1 upon x. We have done it in the chapter of limit, that limit x tends to 0, sine 1 upon x does not lie, so it is not differentiable. So continuous everywhere, continuous at x equal to 0 but not differentiable at x equal to 0. This question has been asked in examination. We have applied two rules. First, we have tested the continuity. According to previous chapter of the continuity. Then I have applied limit x tends to a, fx minus fa upon x minus a is not existing. So answer is second. Next is fx equal to mod of x minus 1. So let us see, this is fx equal to according to step function, this is 1 minus x when x is less than 1, x minus 1 when x is greater than or equal to 1. In the previous chapter, in the chapter of last video, in the continuity, we have seen it is continuous at a 1, because in left of 1 it is 0, right of 1 it is 0, value of the function is f1 is equal to 0, for lesser than 1 it is a polynomial, for greater than 1 it is a polynomial, so it is continuous everywhere. But what about differentiation? What I told you, a function is a step function, and if it is defined in different ways, For less than a and greater than a, then you differentiate it in left, differentiate it right. So what will be the left differentiation? Minus 1. What will be the right differentiation? It will be 1. So function is not differentiable at x equal to 1. Differentiable and continuous on x equal to 1, but not differentiable at x equal to 1. Let us see next question. Fx equal to x greatest integer x at x equal to 0. If you take as a question of continuity, left limit will be at 0 will be 0, right limit it will be again 0. So let us now check its differentiability. Limit h tends to 0, fx x greatest integer x minus f0 0 upon x minus 0. X and x will get cancelled. So this will be limit x tends to 0, greatest integer x. Now according to previous chapter of the limit, we do know it that limit x tends to 0, greatest integer x is not existing because 0 minus h shall go to minus 1, 0 plus h will go to 0. So what we say, function is continuous but not differentiable. Function is continuous but not differentiable. This is very important question. What you have to do, first check the continuity at x equal to 0, find left limit, find right limit at 0, and then check the differentiability according to the principle limit x tends to a fx minus fa upon x minus a is finite, function will be differentiable, otherwise it shall not be differentiable. Fx equal to mod of x plus mod of x minus 2, same question. Fx equal to greatest integer x. So he is studying what is f dash half. What is f dash half? So limit x tends to half, greatest integer half minus fx minus f half upon x minus half. See it again. F of limit h tends to 0, half plus h. This will go to 0, 0 upon something, this will be 0. Similarly, limit h tends to 0, half minus h minus greatest integer half upon minus h. This will be 0 upon something 0. So left differentiation is equal to 0. Right differentiation is also 0. So answer is 0. This is a good question. Next is fx equal to e raised to mod of xa. In the similar manner, you can do it. So, question number 8. This is very important question. ये कहता है कि fx equal to x raised to m minus 1 sin 1 upon x. So, what is the value of m if function is continuous and differentiable at x equal to 0? Let us see. If I check limit x tends to 0, fx minus f0 upon x minus 0. This should be so this is limit x tends to 0. X raised to m minus 1 sine of 1 upon x so limit x tends to 0, this will be x raised to m minus 1 sine of 1 upon x. Now we do know it that limit of the sine of 1 upon x does not exist. So one thing is sure that m minus 1 cannot be 0. M minus 1 cannot be 0 because in that condition what shall happen? It will be sine 1 upon x. So let us see if it is differentiable at x equal to 0, limit should exist. So m minus 1 should be greater than 0. So answer is m is greater than 1. This question has been. So for m is greater than 1, it is differentiable, and when it is differentiable, it will be continuous.